everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. In this session, I am going to discuss about external treatment of water and desalination of water. In this session, I am going to discuss about what is boiler feed water, internal treatment of water, external treatment of water. In external treatment of water, I will discuss about ion exchange process and other processes, reverse osmosis process. First, we should know what is boiler. So, what is boiler? Boiler, also called steam generator. This is an apparatus designed to convert liquid to vapor. So, this is steam generator. So, it will convert water to vapor. So, this is called as steam. So, boiler, it is also called as steam generator. This is an apparatus which is designed to convert a liquid to vapor. So, water to steam. So, this is called as boiler. So, in a conventional steam power plant, so a boiler consists of a furnace in which fuel is burned. So, it is consists of furnace. It is consists of furnace. In this, we will have fuel. So, this is burned. So, this is burned. This boiler is consist of furnace in which fuel is burned. So, the surface is to transmit heat from the combustion products to the water. So, and a space where steam can form and collect. So, in this we will use furnace to generate water to vapor. So, this is in furnace we will use fuel which is used for it is burned, and it is the heat which is comes from the furnace. This is useful for the conversion of water to steam. So, this is about boilers which are used in industry. So, what is boiler feed water? So, this is the water mainly used in boilers for steam generation is known as boiler feed water. So, for steam generation, we need water. The water which is used in boilers for steam generation is known as boiler feed water. So, for such water, we need some specifications. So, for that water should have some specifications. So, the hardness of water should be below 0.2 ppm. The hardness should be below 0.2 ppm, and its castic alkalinity. So, example NaOH, KOH, CaOH. So, calcium hydroxide. So, it's due to this OH minus ions, alkalinity increases to water. So, its castic alkalinity due to OH minus should be in the range of 0.15 to 0.45 ppm. The castic alkalinity, it should be in the range of 0.15 to 0.45 ppm. Its soda alkalinity, so it is due to CO3 minus 2 and carbonates and bicarbonate ions. So, this should be in the range of 0.45 to 1.0 ppm. So, this should be 0.45 to 1 ppm. And it should be free from dissolved gases like oxygen and carbon dioxide, and also it should be free from suspended impurities, turbidity and oil impurities. So, it should be free from suspended impurities, turbidity and oil impurities. So, the boiler feed water, it is having some specifications. The hardness should be below 0.2 ppm. Its castic alkalinity should be in the range of 0.15 to 0.45 ppm. The soda alkalinity should be in the range of 0.45 to 1 ppm. And it should be free from dissolved gases, and it should be free from suspended impurities, turbidity and oil. If excess of these impurities this will cause some problems in the boilers. So the impurities, if we have more impurities in the water, boiler feed water, so these will cause some problems. So these are scale and sludge formation, corrosion, priming and foaming, caustic embrittlement. So the impurities, these will cause the problems in boilers. So that problems are scale and sludge formation, corrosion, that is boiler corrosion, and priming and foaming, caustic embrittlement. So these problems will occur due to the impurities which are present in water. So these scales are hard deposits. So these will stick to inner surface of the boiler. So these scales are hard deposits. These will sticking to inner surface of the boilers. So sludge, this is a soft and loose. It is a slimy precipitate formed within the boiler. It can be easily scraped off with a wide pressure. So scale is a hard deposit and sludge is a soft. It is a soft deposit. It is loose, slimy precipitate formed within the boiler. It can be easily removed off by using wide pressure. So foaming it is a production of continuous foam or hard bubbles. It is a production of continuous foam or hard bubbles in boilers. So here foam will takes place. So foaming is due to presence of substances like oil in boiling water. So due to presence of oil in water, so we will have foaming problem in the boiler feed water. So priming means it is the process in which some particles in water are carried along with the steam. So in this process, some particles in water, these are carried along with the steam. So the resulting process is called as wet steam. That resulting process is called as wet steam, or it is also called as carry over. It is also called as carry over. So the process of formation of wet steam in boiler is called as priming. So in this process, some particles in water, these are carried along with the steam. So this process is called as wet steam or carryover process. So this is due to this process, formation of wet steam takes place. Here, this wet steam in boiler is also called as priming. This wet steam is also called as priming. So what is a caustic embrittlement? So this caustic embrittlement here, boiler corrosion which takes place due to presence of highly alkaline water in boiler is known as caustic embrittlement. So this is corrosion. So this is a boiler corrosion which takes place due to presence of alkaline impurities like basic impurities pH more than 7. So like sodium hydroxide, KOH. So any alkaline impurities, due to any alkaline impurities present in water, the boiler corrosion will takes place. That corrosion is called as caustic embrittlement, because this embrittlement takes place because of caustic impurities which are present in water. So what is boiler corrosion? So here degradation or destruction of boiler materials. So example iron. So it is due to the electrochemical attack is called as boiler corrosion. So we know that corrosion is the degradation or destruction of any metal. So here we are using iron boilers. So boilers, these are made up of iron or steel. So these will undergo corrosion because of the electrochemical attack of the water and which are water and impurities present in water. So impurities and water. So this type of boiler corrosion takes place because of impurities and water. This corrosion occurs. So this is a degradation or destruction of boiler materials due to electrochemical attack is called as boiler corrosion. So these types of disadvantages are there because of boiler feed water which is containing highly impure water. So we will have scale, sludge formation, priming and foaming, and caustic embrittlement, boiler corrosion will takes place due to presence of water, due to presence of impurities present in water. So to overcome this, to avoid this, so we have to soften the water. So we have different water softening methods. So first one is internal treatment, second one is external treatment. So we have to treat the water to soften. So hard to soft. We have to convert hard to soft. So this soft is very useful in boilers. So these can be used in boilers for steam generation. So in this method, internal treatment and external treatment process are there. So for what is internal treatment? So this is accomplished by adding suitable chemicals to the water in the boiler. So in the internal treatment, we have to add suitable chemicals to the water in the boiler. So for most low capacity, low pressure heating boilers, this internal treatment is the only method to prevent scale, corrosion and sludge formation. So in this internal treatment, we are adding suitable chemicals. We are adding suitable chemicals into boilers. Suitable chemicals to the boilers. So this is internal treatment. So here, due to this internal treatment, so we can prevent scale, corrosion and sludge formation in the low capacity, low pressure, low capacity and low pressure boilers. So this internal treatment is used for most low capacity, low pressure heating boilers. This internal treatment is the only method to prevent scale, corrosion and sludge formation. So if for low capacity and low pressure boilers, we have to use internal treatment methods. In this method, we have to add suitable chemicals to the boiler which is having boiler feed water. So some methods are there, internal treatment methods: colloidal conditioning, carbonate conditioning, phosphate conditioning and colgan conditioning. So in this method, we are adding chemicals. So these are 4 types: colloidal conditioning, carbonate conditioning, phosphate conditioning and colgan conditioning. In colloidal conditioning, so we are spreading the organic compounds like tannin, agar, gel. So in this process, we are spreading the organic compounds like tannin and agar, gel. So here we are adding organic compounds to the water. So examples: tannin and agar, gel. So in carbonate conditioning, so addition of carbonate compound to the water. So to remove the impurities, in carbonate conditioning, we are adding carbonate compound. In phosphate conditioning, we are adding phosphate compound. In colgan conditioning, we are adding sodium hexametaphosphate. So colloidal conditioning, carbonate conditioning, phosphate conditioning, colgan conditioning. So in this colloidal conditioning, so we are adding organic compounds like tannin and agar, gel. Carbonate conditioning, addition of carbonate compound. So in this phosphate conditioning, we are adding phosphate compound. In colgan condition, we are adding sodium hexametaphosphate. So this is about internal treatment of water. So external treatment of water. External treatment is the reduction or removal of impurities from the water outside the boiler. In the case of internal treatment of water, so we are adding the suitable chemicals to the boiler feed water in boilers. So in external treatment, so here we are reducing or removing the impurities from the water outside the boiler. So first we have to remove the impurities, then we have to feed to the boilers. So this is external treatment of water. So in this, general, external treatment is used when the amount of one or more of the feed water impurity is too high to be tolerated by boiler system in question. So this is used for more of feed water. So if feed water is having high impurities, boiler feed water which is having high impurities, and it is, so the internal treatment is used for low pressure boilers. So low pressure boilers. In external treatment of water, it is used for the water which is having more impurities. So we have to remove the impurities before feeding to the boilers. So this is called as external treatment of water. So some methods are there. So methods of external treatment of water. First, softening water are, so some methods are there. So zeolite process, lime soda process, ion exchange process. By using these three processes, so these are used for the external treatment of water. So we have to treat before going to feed the water to the boilers. So zeolite process. In zeolite process, we are using zeolites for softening of water. So some here this sodium zeolite is here we are adding. So the formula is Na2, Al2, Si2, O8, XH2O. Sodium zeolite are used for the softening of water in external treatment of water. In lime soda process, the hard water is treated with lime, that is calcium oxide or calcium hydroxide first, then after that it is treated with soda. So in lime soda process, first this is treated with lime, so that is calcium oxide or calcium hydroxide. After that, this is treated with soda. So in this process, we are using lime and soda to soften the water. So next step is ion exchange process. In ion exchange process, it is a chemical process to remove unwanted dissolved ions in water and wastewater by exchanging specific ions for ions that have same charge. So in this, ions are exchanged. So in this process, ion exchange process, ions are exchanged. The ions which are having same charge. The ions which are having same charge are exchanged, and by this exchanging process, we are softening the water. So this is ion exchange process. In external treatment of water, we have three processes: zeolite process, lime soda process, and ion exchange process. So what is ion exchange process? In this, ion exchanges process are two types. So one is anionic and cationic. Ion exchange process are two types. One is anionic, second is cationic. So these are copolymers of styrene and divinate benzene. So that is long chain organic polymers with microporous structure. So these ionic exchange resins. So to ion exchange process, we are using resins. So these are made up of long chain organic polymers. These are long chain organic polymers. Long chain organic polymers which are having porous structure. Long chain organic polymers which are having microporous structure. Microporous structure. So ion exchange resins are long chain organic polymers with microporous structures. So examples, these are copolymers are styrene and divinyl benzene. Styrene and divinyl benzene. So this cation exchange resins. The resins containing acidic functional groups such as COOH, SO3OH, etc. These are capable of exchanging their H plus ions with other cations or cation exchange resins, other cations. So these cation exchange resins represented as or H plus or H plus. Here cation exchange resins. So these are also long chain organic polymers, but these are having functional groups like CO carboxylic acid, sulfonic acid, SO3H. Like here these are having, so these are having H plus ions. These are having H plus ions. So these are capable of exchanging their H plus ions with other cations. So the cation exchange resins are having COOH and SO3H. So these are having H plus ions. These are having H plus ions. So these are capable of exchanging their H plus ions with other cations. So if we place any H plus any cation, so here I am taking Na plus. So if this is exchanged by this Na plus ions, so when we use this cation, so this will, the H plus ion is replaced with sodium plus ion and this will form COONA plus H plus ion. So this is about cation exchange resin. So these are long chain organic polymers with a microporous structure. So these are having COOH and SO3H groups. So these are having H plus ions which are capable of exchanging exchanging other cations. So these are represented by RH plus. So these cation exchange resins represented by RH plus ions because these are replacing their H plus ions with other cations. So another one is anion exchange resin. Anion exchange resin. So this is also long chain organic polymer. So this is containing amino or quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups. So the resin which is containing amino or quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups. So these are treated with NaOH solution become capable of exchanging their OH minus ions with other anions. Means these anion exchange resins having OH minus ions. So these are the amino or quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups. When treated with NaOH solution, they becomes OH minus ion. So these are having OH minus ion. So these are capable of exchanging the OH minus with other anions. So these are called as anion exchange resin and these are represented by ROH minus. So these are represented by ROH minus. So and cationic exchange resin is represented by RH plus. Here ROH minus means here negatively charged ions exchanged this OH minus ion exchanged any other anion. So here I am taking chlorine. So this will have a capability of exchanging these chlorine ions. So with OH minus, here we will get RCl plus OH minus. So this is the work of anion exchange resin. So this is having OH minus ion, cationic exchange resin. This is having H plus ions. So cation exchange resin used for the replacement of cations from the water and anionic exchange resin is used for the removal of anionic impurities in the water. So this is about resins, cation exchange resin and anionic exchange resin. So these are the structures of cationic and anionic exchange resin. This is cationic exchange resin. Cationic exchange resin. This is anionic exchange resin. So this is having SO3H groups, means it is having H plus ions, so which are useful for the replacement of cations from the water. So this is having chlorine. So when these are treated with NaOH solution, we will get OH minus. OH minus. Though these ions are used for the exchanging anions from the water. So these are the structure of cationic exchange resin. This is the structure of anionic exchange resin. So what is the work of cation exchange resin? What is the work of cation exchange resin? So here the hard water is passed first through cation exchange column. The hard water which is having impurities, this is passed first through cation exchange column. It removes all the cations and equivalent amount of ions are released from the column. So in this hard water, first we are having, this is a ion exchange process. We are having cation exchanger and anionic exchanger. First this water, hard water, this is passed through the cationic exchanger bed. So this is having H plus ions. So this will replace the cations which are present in water. So mostly we will have calcium plus 2, magnesium plus 2. So these will cause the hardness to the water. So this will removed by the cation exchange resin. So calcium plus 2 and magnesium plus 2 are replaced with the H plus ions which are present in cation exchange resin. Here the reaction is, here we are indicating cation exchange resin as a RH plus or RH plus, and this is reacting with calcium plus 2 or magnesium plus 2 ions which are present in water. So this is removing by replacing. Here we will get R2Ca plus 2 and 2H plus. So this is a reaction occurs during the cation exchange resin, cation exchange process. So the cations from the water removed by H plus ions which is present in cation exchange resin. So this cation exchange resin, it will remove all the cations and equivalent amount of H plus ions are released from this column. So here it is replaces the cations with resin, and it will release the equivalent amount of H plus ions into the column. Here next, this hard water, the water which is not having cations, this is passed through the anionic exchange resin. Here after this, the hard water is passed through anion exchange column which removes all the anions like SO2 minus, Cl minus, CO2 minus, etc. So the release amount of, so and it will release equal amount of OH minus from this column. So here anions, so if water is having Cl minus and SO2 minus and OH, it will have Cl minus 2, CO3 minus 2. So these type of anions, this can be exchanged from the anionic exchange resin. So first we have to pass the hard water through the cation exchange resin to remove all the cations present in the water. Next we have to pass this water through the anionic exchange resin to remove all the anions which are present in water. So the anionic exchange resin, it will release the equal amount of OH minus from the column. So this is the anionic exchange process. First we have to pass the water with cation exchange bed. Then due to this process, cations will be removed. After that, this is this will pass it through the anionic exchange resin. Here we will get the water which does not having anions and cations. So finally we will get the water which is not having anions and cations. Anions and cations. Here we are getting H plus ions from the column. Here we are getting OH minus from the column. So both H plus and OH minus means, so we will get again water. So here this water is free from anions and cations. So the output water is called as deionized water. After this, the ion exchanges get exhausted. After this, the ion exchangers get exhausted. So here we are getting, after ion exchange process, we are getting water without ions. So this water is called as deionized water. So this water is called as deionized water. So after this ion exchange process, the ion exchange resins get exhausted. So how to activate the ion exchange resins? So the cation exchanger, these are activated by mineral acids. The cation exchanges are activated by mineral acid, and anion exchanges are activated by dilute NaOH solution. Here after treating with water, we got R2Ca. So this is treated with dilute HCl. So to activate the resin. So again we will get RH plus and Ca plus 2. RH plus and Ca plus 2. So for anionic exchange resin, so RSO plus 2 OH minus. So this will give ROH plus SO minus 2. SO minus 2. Here, this SO2 minus. We will get SO2 minus. We will get SO2 minus. So like this, we will activate the ionic exchanges by using acids and bases. The cation exchanges are activated by mineral acids, and the anion exchanges are activated by dilute NaOH solution. After this activation, we can use these ionic exchanges for multi-use. So this is about ion exchange resin. In this, we are using ion exchange resins, anionic exchange resins and cation exchange resins. For removing cations, we are using cation exchanges. For removing anions, we are using anionic exchanges. So both these are used for removal of ions which are present in water. So finally we will get deionized water. So this is about ion exchange process. In this we will remove the ionic impurities from the water. So next one is desalination of brackish water. Next topic is desalination of brackish water. So the process of removing common salt, so that is sodium chloride. From the water is known as desalination. So here removing of salt. The process of removing of salt. So that is commonly sodium chloride. So that process is called as desalination. The water containing dissolved salts with a peculiar salty or brackish taste is called as brackish water. So the water which is having dissolved salts with peculiar salty or brackish taste, so that water is called as brackish water. So example, seawater that contains an average of about 3.5% salts is an example of brackish water. So example of brackish water is seawater. So this contains an average of 3.5% of salts. So this is having brackish taste. So this water is tasted like a brackish taste. So here it is totally unfit for drinking purpose. These brackish water, these are not used for drinking purpose. So commonly used method for desalination of brackish water are electrodialysis and reverse osmosis. So two processes are used for the desalination of brackish water. So the first one is electrodialysis, second one is reverse osmosis. Here, first we should know what is osmosis. First we should know what is osmosis. When two solutions of unequal concentrations are separated by semi-permeable membrane. When two solutions which are having two different concentrations which are separated by semi-permeable membrane. Semi-permeable membrane. Permeable membrane, the flow of solvent takes place from dilute to concentrated sites due to osmosis. So here, when two solutions of unequal concentrations are separated with semi-permeable membrane, so this will the flow of solvent, only the flow of solvent takes place from dilute to concentrated sites. So here the C1 concentration is more than C2. So the solvent is moved from C2 to C1. Here C2 is having lower concentration than C1. So the solvent is moved from C2 to C1. So this process is called as osmosis process. Here the semi-permeable membrane, so this does not permit selectively the passage of dissolved solute particles, that is molecules or ions. This semi-permeable permits only certain ions and molecules. So here when two solutions of unequal concentrations, these are separated by semi-permeable membrane, the flow of solvent takes place from low concentration to high concentration. This process is called as osmosis process. Here this process is called as osmosis process. Here low concentration solvent is moved from low concentration to high concentration. So whereas reverse osmosis. So in this reverse osmosis, if a hydrostatic pressure in excess of osmotic pressure, it is applied on the concentrated side. The solvent flow reverses. Means it will flow from higher concentration to lower concentration. The solvent is forced to move from concentrated side to dilute across the membrane. This is principle of reverse osmosis. In osmosis process, the solvent flow from low concentration to high concentration. In reverse osmosis, so solvent is moved from high concentration to low concentration. So because of hydrostatic pressure, it is more than osmotic pressure. See, if a hydrostatic pressure is applied on the concentrated side, so we are taking two solutions which are separated by semi-permeable membrane, but here we are using hydrostatic pressure. On the higher concentration side. Then the solvent flow from higher concentration to lower constant. This is the reverse to the osmosis process. So this is called as reverse osmosis process. Thus in reverse osmosis, pure solvent, it is separated from its contaminants rather than removing contaminants. In this process, we are separating the pure water rather than removing the impurities from the water. So, this membrane filtration is also called as super or hyper filtration. This membrane filtration is also called as super or hyper filtration. In this reverse osmosis, here we are applying some hydrostatic pressure. Hydrostatic pressure. So, because of this hydrostatic pressure, the solvent is moved from higher concentration to lower concentration side. So, in this, we are getting pure water from highly concentrated water. So, in this, we are getting directly pure water without removing impurities. Without removing impurities, we are getting pure water. So, this is about reverse osmosis process. So, what is the method of reverse osmosis? In this process, pressure. So, we have in pressure 50 to 40 kg per centimeter square is applied to sea water and impure water. Sea water or impure water which is to be treated. So, to force its pure water through the semi-permeable, leaving behind the dissolved solids, both ionic and non-ionic. So, in this sea water, so we are applying 15 to 40 kg per centimeter square pressure. So, hydrostatic pressure. So, in this case, this is sea water and this we will have semi-permeable membrane. So, here we will get pure water because of hydrostatic pressure on the sea water. Here the membrane consists of very thin film of cellulose acetate and fixed to either side of perforated tube. So the superior membranes recently developed are made up of methacrylate, polymethacrylate and polyamide polymers, and these are used in recently we are using polymethacrylate, polymethacrylate and polyamide polymers. Polyamide polymers. So these are used as a semi-permeable membrane. These are used as semi-permeable membrane. So these are also called as super membranes. In this method, we are using hydrostatic pressure to get a pure water from sea water. So this is the process of desalination of water. In this, we are removing the salts from the water. We are getting pure water from the sea water. So this process is called as desalination process, and here we are using the reverse osmosis process for getting pure water from the sea water. So what are the advantages of reverse osmosis? So reverse osmosis process has a distinct advantage of removing ionic as well as non-ionic, colloidal and high molecular weight organic matter. So this is a process has distinct advantage of removing ionic as well as non-ionic and also colloidal high molecular weight organic matter. So it removes colloidal silica which is not removed by demineralization. So here we will remove the colloidal silica by using reverse osmosis. This cannot be which is not removed by demineralization. So the lifetime of membrane is quite high, above 2 years. So this lifetime of semi-permeable membrane is high. So that is about 2 years. The membrane can be replaced within a few minutes, thereby providing nearly uninterrupted water supply. So here the membrane can be replaced within a few minutes, thereby providing nearly uninterrupted water supply. So low capital cost, simplicity, low operating cost, and high reliability. The reverse osmosis is gaining ground at present for converting seawater into drinking water and for obtaining water for high pressure boilers. So this reverse osmosis is gaining ground at present for converting seawater. Here this is converting seawater into pure water. seawater into pure water, which is very useful for high pressure boilers. So this can be used in drinking water, used as drinking water, and these are used as boiler feed water. So here by using reverse osmosis, where desalination of seawater takes place. Here we are desalinated of seawater by using reverse osmosis process. Here we are converting seawater to the drinking water. So which is also used for boiler feed water. So this is about ion exchange process and reverse osmosis process. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.